I thought I'd give a little demo of what I'm working on here. It's a virtual machine for a combinator algebra um, that is quite simple at its core. There's function application, there are laws, which is the word for functions, um, natural numbers, and um, pins, which show up with these brackets. Basically, um, laws are the things that get pinned in general. And only those four kind of fundamental uh, item types. And it's also lazy. Um, and out of that, you can get some essentially full featured functionality. Here I've got a Fibonacci sequence generator. If we step up the number of steps and the number of input, you can see this is generating, the first several Fibonacci numbers. It is, because I've written this as a virtual machine, I can control the number of steps that get executed. And down here is the full heap, all the memory, and then this is a summary of the active heap. I don't have any garbage collection implemented yet, but it's pretty easy to walk the heap to see what's live. Um, so that is why this is a summary. Over here you can see we've got the laws that get referenced. There's this combinator algebra requires everything to be in head normal form, something like that. So you can't have nested functions. So this gets pulled out and becomes zip underscore one. This one gets pulled up and becomes zip one, two. Same with drop. We've got a couple nested. The other interesting thing is lets all have to be immediately the first things in a function definition. You can't have lets nested, but because everything's lazy, you can just hoist all lets to the top of the function, and semantically it doesn't make a difference. Right now, I'm trying to figure out what there's I think a bug where I'm putting a bunch of the same stack frames on the stack. A stack frame in this VM consists of essentially just a pointer to some place in on the heap in memory. So this is saying evaluate 290, please. App with a round bracket means it's already been evaluated. With a curly bracket means it's unevaluated. The reason you would have evaluated applications that haven't resolved to something like a number is it might be the thing in the function place might not be callable. For example, it could be a natural number, and that is the way that lists are represented, where 0 applied to 1 applied to 2, so that the head is the target of the function application, if you will. So 278 or 287 over here is the number 5. So this is 5 applied to 338, whatever that is. So that's what I've got going here, and it's a lot of fun to play around with. Here you can see, at the very beginning, we're calling Fibonacci with a number 58, and we step through. And when we have a function application like this, we just take the body of that law of that function, which we can see down here as fib. And so these are the memory. This is kind of the heap for this function, and we just copy this onto the heap, this list of values, modifying any local references to then be the absolute value, like this. So this is referencing 4, and obviously when it's on the main heap, 4 won't be the right number. So you can see if we go over here, it's now, turns out it's 24. And stack references are references to the arguments that will be passed into fib, and those get resolved just as the pointer to wherever the argument was coming from. In this case, we can see it was line 18 is the stack reference for stack number 1. So we can see pin 5 stack number 1 is going to be to 18. So pin 5 to memory location 18. That's how that gets substituted. And then we go through and say, okay, this target here needs to be resolved. And, or I guess take requires multiple functions, or multiple arguments. So now we can pop in the body of take, and then we can just keep going through. And sometimes it gets very large. Here's the bug that I'm trying to track down. We'll see what it turns out to be.